Hi there. Are you someone who's trying to improve how your applications or services communicate with each other? Have you ever faced a challenge of deciding between push or pull communication models and wondered which is better for scalability and reliability? If you're involved in software development, especially in enterprise level applications, understanding these models can make or break the efficiency of your systems. I've spent years in the field working on complex enterprise systems, and today I'm going to share some insights that will help you make an informed decision about when to choose pull, push, or even a hybrid approach. By the end of this video, you will have a clear understanding how these models work, their pros and cons, and how to choose the best one for your scenario. So here's what we are covering today. We'll dive into push communication, pull communication, and finally, we'll introduce a third option that combines both approaches. Stay tuned because it all connects in the end, and you won't want to miss the practical tips coming up your way. Hello and welcome back to my channel. My name is Samuel Netin, and on this channel we talk about coding tips and tricks, software architecture, and how to elevate your software development career to the next level. Today we'll be discussing the push and pull communication models, two fundamental approaches that not only apply to how applications communicate, but also how objects and functions interact within your code. Let's get into it. The first thing I want to talk about is the push model. In the push model, data is sent to another service or system without the system requesting for it. This is what we call autonomy. You send the data and it becomes the responsibility of the recipient to process it, store it, or act on it. A great example is when you send notifications or updates from one system to another. You are not waiting for them to ask for the data, you are proactively pushing it their way. The beauty of this approach is that once the data is sent, the sender is done with its job. It's up to the receiver to do whatever they need to do with that information. This can be extremely efficient, but then there are some downsides. Now let's talk about pull. This is the opposite of push. In a pull model, services request for data when they need it. It's similar to how you use the search engine. When you need information, you go to the search engine, type in whatever you want, and pull the results of what you searched for. The key advantage here is that you have the authority and you decide when to pull the data. This model works great for scaling because the central system has to serve data when it's requested for. However, there's a potential risk of creating a single point of failure if the central point that stores the data goes down. You know what? There's a third option, which is the combination of push and pull. It's called push to pull model. Here's how it works. Instead of constantly pushing data or having services repeatedly ask for updates, you send a ping or signal to let the service know that there's something new available. This way, the services can then pull data only when they are ready, this reduces the unnecessary back and forth communication and reduces the stress on your services. Think of it as sending out a broadcast that says, hey, there is new data available, and letting the interested services come pick up what they want when they are free. This hybrid approach offers the best of two worlds, autonomy and authority, without overwhelming your services and systems. Now let's quickly recap. Push gives you autonomy and allows your services to work independently even if the central system goes down. Pull, on the other hand, gives you the control and authority to making it easier to scale, but then it introduces the risk of failure if the central system goes down. Push to pull model combines the strengths of both, reducing unnecessary workload while keeping the system efficient. It can, however, be very hard to manage if you have too many services that need updates at different times. Here's an extra tip that really brings this home. If you are using any of the models, especially the pull model, but want to make sure your system doesn't experience any bottleneck, consider implementing a message queue. This allows you to store messages or data requests in a queue and process them asynchronously. Even if a service isn't ready to pull data, the message queue can hold those requests until the service is ready, ensuring that no data gets lost and that your system continues to operate smoothly. In my next video, we'll be looking into message queues, how they work, and what to look out for when implementing them. If you found this helpful and want to stay updated on future videos where we cover more advanced software development concepts, be sure to subscribe and hit the notification bell so you don't miss out. I've got some really exciting topics coming up and you'll definitely want to hear about them. Thanks for watching, keep building, keep growing, and see you in the next one. Ciao.